All right, hello all. We are doing 4.3 in Math 161, which is logarithmic functions. So our goals for the day is we're going to understand just what a logarithm is in general, learn how to convert from exponential to log form and vice versa, figure out how to compute them, evaluate them, and learn something called change of base, and then learn how to solve just simple log equations. So that's on the agenda for today. So to start, if we're trying to figure out what a log is, so if you think about an exponent and you have something like a to the x equals b, a is the base of the exponent. When you convert it into log form, that becomes the base of the log. And then this is saying a to the what gives you b, so that b becomes the piece in here, or the domain of the log, and then we put equals x. So that's going back and forth between exponential to log form. So again, those two are going to be equivalent. And what a log is then is it's the inverse of an exponential function. So you can use them to undo each other. So just like if I did 1 over x and then wanted to undo it by multiplying by x, etc., it undoes. So again, it's the inverse, and then we have this conversion where we can go back and forth. So essentially what exponent x to when you put it with a gives b as a result. So if I had 2 to the third equals 8, I would change that to be log 2, 8 equals 3. 2 to the what gives me what? So kind of in a circle like that. Yep. All right, so if I keep going, we have a couple of these properties. So remember, these are inverses. So if we think back to our composition of functions, if you compose an inverse with its function, you should get back out what you started with, which is x. So if I take, log base 2 and then take 2 to the third, they'll essentially cancel and give me back out the 3. They're inverse properties. And then if I take that same 2 and log to the 2, those will cancel out and I'll get 3 equals 3. So make sure to kind of know those properties with the inverses, that if you raise a power to the same log base, it essentially cancels out to 1. If you take a log base and then put the exponent with that same base, it essentially gives you back out your 1. So kind of just keep those in mind. Okay, and then our other properties, this statement is how you go back and forth. So make sure to absolutely know this conversion. And that's that conversion. If I have, 2 cubed equals 8, it becomes log of 2, 8 equals 3. So definitely make sure to know this conversion. So you want to know your inverse properties, and you want to know log conversion to exponential and vice versa. All right. So a couple of basic ones to start out with. We have 5 squared equals 25. We know that 5 times 5 is 25. So if I write this out, this becomes 5, and I'm just going to color code it for a second. Squared, whoops, and I have equals this 25. Okay, so I've written it so we can kind of see how this is going to work. So we're going to have some log now with a base and an equals. Okay, so what happens is the base of the exponent, the 5, becomes the base of your log. The answer you had originally, the 25, becomes the domain or input of the log, and the exponent comes on the other side of the equal side, so it switches which side it's on. So those become equivalent to one another. So you might want to pause and try this next one before I go over it, but I'm going to rewrite it to be 10 to the negative 4 equals 1 over this 10,000. Okay, so if we go put this in log form, we've got log of something equals. Okay, so the base of the log, what I'm writing in red, comes down. Base of the exponent was base of the log. The -4, which is the power, comes to the other side. And then the answer now becomes the domain. So this is telling us 10 to the -4 is equal to 1 over 10,000. Okay. So pause if you're still writing that down. Otherwise, I'm going to continue. All right, so then we can convert backwards as well. So I'm going to write this with a similar color coding, log of 6. And then this has an input or a domain of √6 equals this 1/2. Okay, so when I rewrite it, that 6, which is the base of the log, is now the base of the exponent. The green, which is the answer, is now what we're raising it to. And you get the square root of 6. And we know that that makes sense. Anything to a square root is then the square root. 1/2 is the same as the square root. So we have converted it that way. So then this piece becomes the base. 3 squared equals 9. And we've converted it. If it doesn't make sense, kind of think back. If you wrote it in the wrong way and you wrote 9 cubed equals 2, well, that doesn't make sense. So kind of make sure at the end that what you're writing does make mathematical sense. Okay. All right, then continuing, we have something called a common log or a natural log, and that's that idea of this E. So E is a button on your calculator. It's approximately 2.71 da 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 da, but it's a little more special. It's a natural log with a base E is now called ln. Whereas a common log has a base 10 and it's usually written log. So when you punch this button on your calculator, it's assuming you're doing a log base 10. It can't do other ones, but we'll get into how to do those. When you punch in ln of x, it's assuming you're doing a log base e of x. So those are two that you really want to take note of: common log, natural log, log base 10, log base e. And then we abbreviate them as this log and natural log button. Okay. So for this problem, if we want to evaluate it, ouch, I'm going to rewrite this. Whoops, I don't want my highlighter. As log base e, and then I'm going to rewrite this as e to the half. So that becomes one of those inverse properties, and we are left with 1/2. So this is saying e to the half basically equals e to the half. So our answer is half. Okay, continuing on. If we look into solving equations with logarithms, if it's not immediately obvious, you might want to see if you can just do a conversion and if that works a little bit better for you. And if that doesn't work, we'll keep going with some other things that we can do. So to start, if I put this in exponential form, because I don't know what the log 4 is, but if I move this and say 4 squared equals x, what's 4 squared? 16. So now I'm able to finish that log. Log base 4 of 16 is 2 because 4 squared equals 16. So if you're not sure, just see if the conversion makes it look a little nicer or makes it a little more doable. So to convert this one, the base of the exponent becomes the base of the log. The number it was equaling becomes the input, and then we would put equals x. So why I did that is because we're solving for x. And we leave it like this. This, whatever it is just a number. It really is. We don't have the button for it, so we're just going to leave it. But we did solve for x. It's whatever log base 2 of 10 is. And so you are done leaving it in that form. Right? I'm going to keep going to a couple more examples. All right, so we've got another one and we're trying to solve it. So let's start by just kind of figuring out how we can get t alone. First, we should divide by 5. Taking a log immediately is not really going to help us. Remember, a log of a, b equals c is the same as a to the c equals b. But if we have other stuff, we need to get rid of it first. All right, so this leaves us with 1.07 to the 3t power equals 2/5. Now we can convert that into our log form. So this will become our base. The 2/5 becomes our input, and the 3t becomes our answer over there. But we were being asked to solve for t, so you finish it off by dividing by 3. So over here, t is equal to 1/3 log base 107 input 2/5. Okay. And then this is a number. This is truly a number. This log 107 2/5 is just some number. So the question is, how do we get that number? Okay. All right. Let me keep going. If I move too fast, just rewind me. Okay. So on our calculator, we already mentioned, we have 2 buttons. We have log of x, which is log base 10. And we have natural log of x, which is log base e. We don't have the other numbers on there. But if we need to find one, such as that log 107 2/5, we can do what's called a change of base formula, which is going to come in handy for almost all of our log functions. And that says that you can take the log of your 2/5 and divide it by the log of your 1.07 and actually get a number out. So let me erase this board real quick. If we come back up, what we had from this previous problem right here was that t is equal to log 1.07 to the 2/5, all divided by 3. So what we can do with that is we can now say that it's equal to the log base 10, so it's just a number we can type in, of 2/5 divided by the log of 1.07. And these are now both base 10. And again, it's the big number divided by the base number. And that gives us a number. We can punch that in. It's about negative 13.54. T was that divided by 3. So that tells us t is approximately negative 4.51. And we've solved the problem. It really is just a number. And then up here, we have another property, and we'll get to that next class. But just kind of what this is saying is if you have log of whatever base and it's a squared, for example, the 2 can come in front. But again, we're going to come back to that next class. What we want to focus on a little bit is how to do a change of base. And I should note, with a change of base, you can either use log base 10 over log base 10, and then the 2 numbers like 2/5, 1.07, or you can do a natural log of the 2/5 divided by natural log of the 1.07. Either one is fine. It's a ratio of logs, and we're just trying to figure out which buttons we have buttons for, All right, so evaluating this one to go over the change of base. If we want to do the common logs, log base 10, that's your common one. What it turns into is you do log 10 over log of 2. And these are your inputs, and you truly just hit the button log 10, close parentheses, divided by log 2, close parentheses, and you should get about 3.321. If we want to do the natural log, then that changes it to natural log of 10 over natural log of 2. And guess what? Same answer, because we're just doing a ratio of the logs, so it doesn't change anything. All right, that is it. Start your Lumen homework.